All right, let's dive in. Today, we're going to open up the toolkit of a chemical detective. We're talking about the classic, old-school methods for figuring out what an unknown substance is. These are techniques that don't need fancy machines, just sharp eyes and a bit of chemical know-how.
So, picture this. You find a vial. Inside, some mysterious, colorless salt. There are no high-tech labs around, no million-dollar machines. It's just you, this mystery powder, and a few basic chemicals. This is like the ultimate chemistry puzzle, right? And you'd be surprised how straightforward the tools to solve it really are.
So, what's our goal here? It's something called qualitative analysis. And all that really means is we're trying to figure out what a substance is, not how much of it there is. We don't care about the quantity, just the quality. It's the art of chemical identification. And our whole investigation is going to kick off with the most basic clues you can imagine.
Okay, so our first move as chemical detectives, we're going to heat things up, literally. Think of it like a police interrogation. We're going to apply a little pressure, some heat, and see what our mystery substance is willing to tell us.
This first step is called a dry test, and honestly, it's invaluable. You just heat a tiny bit of the solid and watch. What happens? Does it change color? Give off a gas? Does it melt? Or does it just break down? These simple observations, they give us our first crucial clues and help us narrow down that list of suspects right from the get-go.
And check this out, this is what's so cool. Different substances react in completely unique ways. You heat something like ammonium nitrate, and poof, it just vanishes into gas and water. But then you take lead nitrate, and it leaves behind a solid and gives off this very obvious reddish-brown gas. And zinc carbonate, it does this neat trick where it turns yellow when it's hot and then goes right back to white when it cools down. Every single one of these observations is a huge lead.
All right, moving on. Now we get to some of the most visually stunning clues in the entire detective toolkit. I mean, these tests are just brilliant. They don't involve a lot of complicated reactions. Instead, they create this incredible display of color.
Yep, we're talking about the famous flame test. So here's how it works. When you heat a substance in a flame, its electrons get super energized, and they jump up to a higher energy level. But they can't hang out there forever. It's unstable, so they fall back down. And when they do, they release all that extra energy as light. And the best part? The color of that light is totally unique to each element. It's like a fireworks show that's a definitive fingerprint for that chemical.
And this just shows you how specific those fingerprints really are. Sodium, that's that intense golden yellow, like you see in old streetlights. Potassium gives off this beautiful pale lilac color. Calcium is a solid brick red, but strontium is an even deeper crimson red. And barium, wow, it burns with this incredible apple green. If you see one of these colors, that's a massive clue about what you're looking at.
There's another cool technique that's kind of similar called the borax bead test. What you do is you melt a little bit of borax on a wire loop until it forms this clear, glassy bead. Then you dip that bead into your mystery powder and heat it up again. And what happens is some metals will actually get trapped in that glass and create these stunningly colored beads. Copper, for instance, makes a striking blue bead. Chromium makes a vibrant green one. It's just another awesome visual confirmation.
Okay, so we've got some initial clues from the heat and color tests. Now it's time for the final interrogation. We're bringing in the heavy hitters. This is where we use specific chemicals to really force a reaction and get our suspect, the anion, to confess its identity.
Now here's the thing. A good detective doesn't just go in with the toughest questions right away. You start with a soft approach. In our case, that's dilute sulfuric acid. It works on the easy targets, the anions that react easily, like carbonates. They'll fizz and bubble. But if that doesn't get us a confession, then we bring out the tough approach, concentrated sulfuric acid. This stuff forces even the most stubborn anions to react and show us what they're made of.
And this quote really gets to the heart of why that tough approach is so effective. See, when you add concentrated sulfuric acid to something with bromide or iodide, it's not just a simple reaction. The sulfuric acid is a powerful oxidizing agent, meaning it basically rips electrons away from the HBr or HI that forms first. That turns them into bromine and iodine gas, which, luckily for us, are colored. It's a two-step reaction that gives us a dead giveaway.
Okay, now for a super specialized tool. This is for when we think our suspect might be the chloride ion. It's called the chromal chloride test, and it is absolutely unmistakable. You mix your stuff up with a couple of chemicals, heat it, and if chloride is there, boom, you get these incredible deep red fumes. But, and this is a big but, there's a critical catch. Your test tube has to be bone dry. Why? Because that red vapor reacts with water instantly, and it'll destroy the very evidence you're looking for. One drop of water and your test is ruined.
All right, our toolkit is ready. We've got our dry tests, our flame tests, our acid interrogation methods. So let's put it all together and crack a classic chemical case.
Okay, let's open the case file. The mystery of the blue ring. We have an unknown compound, and our job is to figure out what it is. The lab has already collected the first couple pieces of evidence. Let's take a look at the log.
Okay, so here's what we've got. Clue number 1. We hit the compound with concentrated sulfuric acid, and it gives off a reddish-brown gas. Interesting. Clue number 2. We do a follow-up test, carefully adding some iron sulfate, and a very distinct colored ring forms right at the boundary between the two liquids. That's it. 2 clues. But believe me, for a chemical detective, that's plenty.
So, let's think about this. What chemical suspect do we know that gives off reddish-brown fumes with concentrated acid and forms that famous ring? This specific combination of clues, well, it can only point to one culprit. The identity of our mystery substance is about to be unmasked.
And the culprit is the nitrate ion. The evidence is just overwhelming. The nitrate reacts with the concentrated acid to produce nitrogen dioxide, that's our reddish-brown gas from the first clue, and then that reaction with the iron sulfate, it forms a special complex ion that creates the famous brown ring, which is the classic slam-dunk test for nitrate.
So, how did we crack it? We just followed the procedure. We analyzed the clues from both tests. We consulted our chemical playbook, so we knew what to look for. That unique combo, the brown gas and the brown ring, let us rule out all the other possibilities. And just like that, the evidence confirmed the identity. We went from a total mystery to a positive ID. Case closed.
You know, it's pretty amazing. This simple toolkit shows just how much you can figure out just by watching carefully. Seeing how things react to heat, to flame, to a few basic chemicals. It's a great reminder that even with all our modern tech, the heart of chemistry is still just observation and good old-fashioned deduction. Every chemical tells a story. The real question is, what other stories are out there just waiting to be told?